Okay, next up, we're pleased to have Rachael Z. Miller with us. Rachel's a co-founder of the Rozalia project, which you're going to learn about if you don't know it already. Is also co-founder and executive director of that. She holds a U.S. Coast Guard 50-ton master's license and captains a 60-foot sailing research vessel called the American Promise, amongst her various duties. Her academic background is in marine studies and underwater archaeology from Brown University. And today she's, I think, going to focus mostly on a project which she's part of the design team for something called the Cora Ball, which she has in her hand. And that's a consumer-based solution to microfiber pollution, which we'll learn more about right now. Please welcome Rachael.
Thank you. Thank you for having me. I'm really excited to be here. Okay. Our clothes are leaking. Steve talked about leaking. We have a big leak in that our clothes are breaking up and they are leaking out into our public waterways. That's what it looks like, all in a jumble. And it's going through the marine food web and ending up on our plates. So I am going to talk about microfiber pollution, but I did want to introduce you to Rozalia Project. We are a nonprofit whose mission is to clean and protect the ocean. We've been at it for a little over just 8 years, and our focus has been on marine debris. We use different strategies to address the problem of marine debris, and it's one of the things that sets us apart from other organizations. First is that we use multiple angles. So we are doing cleanup, and we're doing prevention through education programs. We are embracers of innovation and technology, and we do solutions-based research. So it's not that we're just focused down one of those paths, but we're using those different strategies together to achieve our mission. We are also, from the start, we've been working on the problem of marine debris in the whole water column, surface to sea floor. And we do that without throwing anyone overboard. So obviously shoreline is easy to access. The surface, we use a variety of nets and boat hooks and things like that. And we use an underwater robot, an ROV. His name is Hector the Collector, because we do more than just look at what we see, the trash underwater. He's got a gripper, and we can pick it up as well. Our focus very deliberately and from the start has been on the land-sea interface in our urban and coastal waters. We respect the work that's happening out in the center of our ocean gyres, but for us, the source and solutions are most efficiently and best found at the land-sea interface. Not just for the stuff, the trash itself, but for the people factor. And these kids are having what we call ROV face, just so you know what you're looking at. They're seeing underwater in real time for the first time. So they're looking at the ROV screen. And honestly, I think, just discovered a tire is what they're so excited about. We work with a lot of great partnerships, from academic and waterfront organizations to various organizations who help us do what we got to do, including the American Chemistry Council, an organic candy company called Surf Sweets, and the Schmidt Marine Technology Partners and 11th Hour Racing. And finally, we're optimistic. In the face of this overwhelming problem, we are optimistic because we recognize that the sort of collective we made this problem, and we believe that the collective we can solve it. Lastly, we get to operate from a great research vessel. We have American Promise in the Gulf of Maine. We're home ported in Kittery, and our operating area has been, call it New York to Bar Harbor. She's the greenest research vessel in the world and has some cool history. You can read about it online, but the short version is that this boat held the nonstop solo circumnavigation record under the leadership of the first American to sail around the world alone without stopping. And we have solar, wind, and hydro systems on board. We haven't turned our generator on in 2 years. Okay, let's go back to our leaking clothes and microfiber pollution. The mechanism for this is the washing machine. It's not necessarily the cause, but this is the land-sea interface where everything that we're wearing is breaking up and flowing into public waterways. When we first learned about this problem, we set out to investigate kind of what sets it up. How does this happen? So we started looking at our clothing through microscopes. It's like a rabbit hole of dorky fun to take a microscope and look at all your clothes underneath it. This is my favorite thermal, and this is my favorite thermal magnified about 100 times. And what we realized is that what you see with your naked eye as one thread is actually hundreds, if not thousands, of very small fibers. Now, this is just editorial on clothing. This is not editorial on clothing. This is just a fact. I am not saying that this is a bad way to make clothing. In fact, that's my favorite thermal. I live in Vermont and I love to ski. And it's thanks to that thermal that I can go out in -20 and have a really good time. So our clothing in its technology is pretty spectacular, but this problem has just recently-ish been discovered, and we'll tell you our thoughts on solving it. Here's a fleece dress. We wear fleece dresses in Vermont. And here's what that looks like magnified about 100 times. Black fleece. Finally, a pair of jeans. This is a pair of jeans that's a mix of ocean plastic and cotton. And there it is, magnified along with a number. The Bren School of Oceanography, at Patagonia's request and funding, did a project looking at the capacity of clothes to shed. And what they found is that one fleece would shed or could shed an average of over 81,000 individual fibers with a high of up to 250. And that study was done without soap. So we suspect, knowing what soap's job is, which is to disconnect things and get them off your clothes, that number could be higher. There's nothing to stop the microfibers right now. As far as filters go, this is a typical filter on a front loader, and it's really just meant to stop your coins or my business card or whatever you left in your pocket from going through your hoses and causing damage that way. It's really not meant to stop this problem that is of the smallest size. And so without anything to stop the microfiber, it is flowing. If you are direct to a municipal wastewater treatment facility, it's going to your wastewater treatment facility, where it appears that one of two things happen. One, it just basically gets through and it flows into the nearest river, bay, lake, or it gets hung up in the sludge. The interesting thing about wastewater treatment sludge is, very smartly, it is very often used as an agricultural fertilizer, which means that the fibers end up on a field. If you're in a septic system and leach field like we are in Vermont, it's either going into the groundwater, and I'd love to see some studies on this, or it's getting cleaned in the 5-year cleaning where it's going to the wastewater treatment. So for Rozalia project, just learning about this and understanding the potential magnitude of it was enough for us to seek a solution. But every now and then I do have people ask, well, why should I care? And the reason that we tell people they should care is the variety of materials that make up this pollution. And we are equal opportunity microfiber picker-uppers. This for us is not just about plastic, but it's about textiles that are covered in a real wide variety of chemicals, heavy metals, flame retardants, and things like that. And like I said before, if it's going into the marine ecosystem and the fish are eating it, it has a pipeline onto our plates. And while we don't know the exact result of the environmentally relevant amounts that are transferring, again, we're not waiting to find out, we being Rozalia Project. So, I did have one more statistic on here for the people that are like, but really, is this really happening? So to look at Chelsea Rockman's paper, she went and purchased fish from a fish market. So instead of just getting them randomly, these are fish that were meant to go to people's plates. And in inspecting the fish, they found that 1 in 3 shellfish, 1 in 4 finfish, and 67% of all the species that they studied had microfiber or microplastic, but it was nearly all microfiber in them. So this really is happening. Now I can say, but don't be overwhelmed, because we have a solution, one to kick things off. This is the Cora ball, C-O-R-A. and I can pass this around for you guys to check out. I'm a good skier, but can someone catch this without me knocking everything over? Oh, okay. So the Cora Ball is a very easy to use solution to this problem, and it's focused on consumers. You drop it or throw it into your washing machine, in any washing machine, and it works the way coral does. So I've already said that a filter, it's not really going to work because we're trying to catch something so small, and we need water to flow. So when we first started designing this, we thought filter, and then we very quickly realized that a filter isn't going to work with the amount of cost it would take to be self-cleaning and or the amount of consumer involvement it would take not to flood basements. So we thought about what nature does, and nature does exactly what we need in the form of coral. Coral lets water flow, and it catches little things that are floating through that water. And so that's what we needed, and that's when you see it, there are stalks that are very similar to coral catching the fibers. So let's see if this works. There we go. It swooshes in your washing machine, and soap, which is job to detach bits of stuff, dirt and fiber from your clothes, floats that stuff to the surface or just detaches it and aggregates it, and the Cora Ball cruises around picking that up. I don't know if you can see, yeah, you should be able to see. So it, as a bonus, collects hair. That's not something we necessarily set to design into this product, but you can see that's useful in our house. We also have these 2 huge Newfoundlands, and it's collecting pet hair and people hair, and those are working to aggregate the fibers. Of course, for us, the fibers are the highest priority. And the amount that it gets varies. So this would be in just a typical person load, summery clothes. They think this is fuzz from 3 loads of a mix of normal clothes and fleece, which would be a pretty fiber-shedding, heavy garment. Sometimes, in one load, you can get quite a bit. So we're seeing up to 35% of the total microfibers that are flowing out, and we did that by hand filtering the effluent. We're getting up to 35% recovery of fibers with the bonus of hair. The way you clean it is like a hairbrush. Essentially, when you see the fuzz balls, you can pull them out. And for now, they'll go into your waste bin. Towards the end, we'll talk about how this fits in the circular economy, and we'll talk about my sort of vision for that. The microfibers that we're aiming to get are very small. The ones that have been found in sea creatures have been smaller even than a red blood cell at 3 microns. And so the question is, can some product like this actually get things that small? And what we've been finding is that we are seeing an aggregation, that little bits of fuzz and hair are helping combine it, and that while we haven't counted them individually or tracked that we've gotten one of 3 microns, I can say with confidence that we are getting the small fibers because of this aggregation factor. So here's a little video that we put together that shows how we know that. So we're just pulling a little bit of the fuzz out of one of our test coras, and then putting our microscope on it and having a look. So again, a lot of this is invisible to the naked eye. And we need the microscope to really track what's going on. So we found a whole bunch of clumps there, and now we found one that is good to zero in on. And here's a still of it. That big, thick, ropey thing is a piece of hair, and you can see all the different colors that have aggregated together into a fuzzball that was actually grabbable. And here's what the size of that, the aggregation in the middle was. It's that little piece right there. So these little fibers are important. And we also needed to understand how this problem looks in the real world. Because we're like, okay, we know these little ones are happening in fish and that kind of thing. So we wanted to understand it. So we took American Promise and a variety of other forms of transportation and sampled the entire Hudson River. From Lake Tier of the Clouds to Ambrose Light. Every 3 miles we took samples looking at microfiber pollution. So this was done with the protocols from adventure scientists so that our data are compatible with data from all around the world. And this is doing grab samples. So by throwing a bucket out, rinsing our arms and rinsing the bucket multiple times, and then taking a sample in a glass jar that had also been rinsed 3 times. We looked at salinity as a factor to see if there was a relationship. We are testing just the top 8 inches of the water. We turned our galley into a vacuum filtration center and took the samples and did the processing right on the boat, and then turned our settee area into a microscope, microfiber counting, laser FTR place that got cleaned up, and then we would have dinner there later. So I can't share the results yet because we've submitted this paper to peer review, but I can say that we found microfibers up and down the whole of the Hudson River. Not just where there was enormous population or an incredibly dense amount of people or even a lot of wastewater treatment facilities. We found microfibers in the Alpine region. We found them in the agricultural sections. We found them throughout the area above the first wastewater treatment plant. Here's some of the samples. Here's a couple more we pulled off of the filter paper so you can see what they look like. Very clearly bright red from textiles of some sort. We also learned that, and this goes with the fact that we found them above wastewater treatment, is that there's another source besides just the washing machines, and that it's likely the air is the way we see it. One, because we had to control for air pollution essentially in our boat, that we had air blanks testing to make sure that we weren't contaminating our samples and attributing random pieces of microfiber that maybe came off our own clothes and attributing those to the Hudson River. We were very careful about a blank protocol and a quality control protocol that included looking at the air in the boat, and found that in order to keep the air blank numbers at a reasonable level, which is nearly none, we needed to close all the hatches and keep everybody still, that we couldn't even walk around. When we got the results back and we found out just how much fiber was above the first wastewater treatment plant, and we realized that there are other sources, I went out behind the house to where our own dryer exhaust is. It had rained 3 days before this picture was taken. We don't do a lot of laundry, so this is maybe 2 or 3 loads of laundry. And these are fibers that were just sitting on the foliage outside of our dryer exhaust. So we're gonna work on that one next as far as the solution goes. But I wanted obviously to talk about this in context of the circular economy. And the way we see this problem is that there are opportunities here. It's a relatively recently discovered problem. So the first opportunity is figuring out how to prevent this leakage. So does anybody have an example or an idea of something that could prevent our clothes from falling apart and those bits falling out? There you guys, a thought? Like something, even if you don't know that it exists yet. Yeah. What's that? Stronger fibers. Awesome. Figuring it out at the actual fiber level. Exactly. So there's an opportunity to prevent this. People are also working on some coatings and things like that. Awesome. So then there's an opportunity to stop the leakage. Clearly, that's what we've gone for in this first solution, is stopping the leakage, helping stop the leakage with the Cora ball. And then another would be to close the loop. So any ideas on how we could, an example of what closing the loop in this context would be? What do you think? For us, it's taking the fibers and seeing if we can upcycle them. So we've been talking a lot about relatively low recycling rates, and maybe asking people to keep their dryer lint and their washer lint is far-fetched, but perhaps if there's some inspiring thing we can do with that stuff, perhaps it isn't so far-fetched, but at least there might be an opportunity. We also see some opportunities for innovation within those challenges, and that there are 4 groups that are involved in this problem, kind of like it or not. This is not a blame thing, this is just a reality. So the first group are everybody in the textile industry. The next are consumers. The next are the industries related to laundry doing, washers, dryers, detergent companies. And the last would be wastewater treatment. So looking at the first, the textile industry, we see 4 sub-industries where there's opportunity for innovation, and it's exactly what you said. So one are so let's isolate the synthetic side. The chemists, the people mixing up resin pellets that will become our clothing. I don't know enough to know if there's room to innovate in there, or if we could figure out if at that level there's something that causes it to break. And then you get the people that take the resin pellets and make filament, so the extruders. I don't know if heat or speed, or there's something in that process that could be improved. And I'm doing what really Rick said, is saying, what can we put some brain power into these industries, in this case, to prevent the leakage? Maybe make the filament stronger. The next would be the people that take filament and they weave it into textile. And there may be something there, something in the weaving process that could make it stronger. And finally, there are the clothing designers, the manufacturers, the people that select textiles and turn them into household textiles, clothes we wear, awnings and things. And maybe there's an opportunity, or not maybe, there is an opportunity there to innovate perhaps something stronger. The second group, consumers. And like we said, this is the group we decided to start with because we have an ulterior motive, and that is to inspire the group we just looked at to get on with some innovation there. Is that starting for us, it was also the fastest way we could start to make an impact on this problem, is get these into the hands of people to start keeping any percentage of our microfibers from washing into public waterways. The next group has to do with laundry doing. And so washers, we've established that that's a problem, and that's what most people are talking about now. Dryers, in our opinion, need to be part of this conversation, because I just went outside my house. I clean my lint trap every single time I do my laundry. So there's a lot of stuff leaking out that way too. And there's a unique opportunity in the form of laundry detergent to maximize depilling or that kind of thing, especially in concert with a leakage stopping device like a Coraball to help prevent this stuff from escaping. And finally, there's opportunities in wastewater treatment, whether that's at the septic system, sort of individual household level, which still is connected, or to the municipal level. Arguably, that's the one that will be the longest timeline. So for us, consumers are the fastest. I'm guessing that textiles and laundry industries might be about on the same, and then this one would be the slowest. We've written our patent to adapt our technology to go into washing machines and wastewater treatment facilities. In terms of impact, we estimate that if 10% of US households used a Coraball, we could keep the plastic equivalent of over 30 million water bottles out of our public waterways per year, using some averages on laundry use. And that's extremely exciting as a start. We weren't sure what the ultimate uptake on this would be, because it's really easy to use. It's this easy to use, to just throw it in and then clean it every now and then. Depending on what you're washing, you don't need to clean it every day. The more dogs and people hair you have, the more frequently you'd clean it. But we launched as a Kickstarter. So our timeline right now is we have 4 days left in our Kickstarter campaign that we launched on March 28th. And our goal was $10,000. $10,000 would get a Coraball to exist. That would be assembling it at the kitchen table, like with our board of directors and my mom and dad and that kind of thing. But we, much to my joy, have exceeded that goal by nearly 3 orders of magnitude. We're at $280,000 pledged, and just under 7,000 people have pledged for this. And what that means to me is there's hope that people are understanding this problem and are willing to take an action, a small action, an action that costs them $20. They're willing to take it on, and they're willing to make some effort. And that, to me, fuels the optimism that we already had. So I hope that you'll share that. There's only a couple days left. We expect to be in production in July, and our distribution partner plans include talking with clothing manufacturers, washing machine manufacturers, laundry detergent, and municipalities. Ultimately, our goal is to close that loop, is to figure out some upcycling opportunities, to work with the individuals, with commercial people, and whomever we can to not just stop this leak, but to figure out a way to put this material back into a usable loop. So thank you again for having me. I appreciate the opportunity.
Thanks, Rachel. I think I was, you honored me by saying I was the first ever to have written a word Korabal in an email to you.
You were. Doug was. He saw the earlier
name.
Version, and we had just
And I
figured
said,
out
"This is
the
pretty good."
name. It's named after Cora, but you were the first.
Question over here?
Hi, Rachel. I'm Rachel with 5 Gyres, and I was so thrilled that you participated in our Microfibers
We
webinar
appreciated
a couple
it.
of months ago, and so thrilled to see how successful your Kickstarter was.
Thank you.
And is, clearly. So my question is, have you looked at the percentages that you are capturing? And also, are you coupling that messaging with the understanding that natural fibers, although they do shed, don't pose the same problems?
We are, so for the percentages, absolutely yes. We are capturing up to 35%. And the numbers have been varying, and we're still learning all of the criteria that contribute to that. It could be anything from the size of the load and what's in there, and if it was dried in between when it was washed again, and all sorts of things like that. But we're getting up to 35%. As far as the message goes, we are talking about plastic as being the most persistent and the thing that we're trying to stop for sure. We are including, the more research I've done about this problem, the more I've learned about our textile industries. And so I have to say that the only thing we're really letting off the hook is organic certified clothing. The more I read about the flame retardants, the dye setting, things that make cotton shiny, it's scary. And so what we have been saying is this is equal opportunity fiber catching, and that the organic, certified organic is really the only stuff that we would feel good about, say, letting go through. But we just as soon keep all man-made things out of the bellies of fish.
Another question? Libby.
I can't wait to get my Korabal.
Great, thank you.
But my question is about the cost or the impact to wastewater treatment plants. And I understand that there's a concern about these getting out into the ocean, into the environment, onto our plates. Is there a cost or implication to a wastewater treatment plant in terms of its ability to treat its water or to reduce its pollutant load that would be helpful to them? What's your angle?
Ooh, that's a great question. And I am not going to make up an answer. I don't know I haven't read anything that specifically quantifies the effect of microfiber on a wastewater treatment plant systems. So I haven't read anything that links those two things. One thing I do know before wastewater treatment, when we're looking at relatively small diameter washing hoses, that there are people who are having to use various creative strategies to reduce their own fiber lint load to keep from having blockages. So that's an excellent question. I don't know how to answer that at this point. Okay, great.
I would guess maybe there's not a cost to the plants now because the holes are so big, but that to put a microfiber catcher on the systems will be costly because it will slow the water flow, and
Right.
then you have to clean it, and that's probably something that they're afraid
If it
to have to do.
yeah, I think you're right. If it became a focus on wastewater treatment, it will be complicated and potentially costly, but not impossible.